one more array example, and then I'm going to talk about functions, and then I guess that'll be it for this week. So after reading week, or after I guess the midterm break, we'll look at we'll spend a lecture looking at some examples of complete scripts, and then we'll transition into C after that. All right, so sorting an array. Bash has no built-in way to sort an array. Right? So you know that there's a sort command, but the sort command sorts lines of text. Right? So it sorts, you have a bunch of different lines of text. Sort will actually will resort the lines of text so that the lines are in sorted order. So you might be able to use that sort command in order to implement your own sort, I guess, algorithm in Bash. So you can sort of do it. It's not perfect, but it sort of works. It works for text anyway. It doesn't work if you have numeric values. So if you have numeric values, you have to write your own sorting algorithm. For text, you can do the following. So the idea is, if this sort command will already sort for me, then all I need to do is I need to take the elements in my array and present them to sort in such a way that sort can do something with it. Right? So sort sorts lines of text. So the idea is loop through your array, right? Output each array element on a separate line, right? Take all of that output, pipe it to sort, right? And then sort will be able to sort that output, right? If you want to save that output, then you're going to capture the output of sort in a command substitution, right? Oh, you do want the output. So you want to capture that output, and then you want to put it back into a new array, right? So print all the elements of the array, one line at a time. Send the output of that to sort, to let sort the output. Then take the output of sort and put the elements and put each line of sort into an array. Okay, so this is what it looks like. It's surprisingly short given what you're doing, right? So I got a little script here called asort. This one reads the elements of the array from from standard input, right? So it prompts the user to type in some strings. And now all of these steps here: output each element of the array to be sorted, one element per line using a loop. So there's my loop. Right? So for each element E in the array, right, I'm going to print each element of E. Right? So that's my loop. Now notice that's all a single command. Right? So a loop on its own you can consider that to be one command. So it's called a compound command, right? Because inside the loop body there's other commands. Right? So I can take whatever that generates, right? Whatever that entire loop generates, and I can pipe that to sort. Right? Now sort is going to output the sorted output to standard out. Right? So I can capture that with a command substitution. Right? And so elems is now a variable that stores the sorted array elements where each element appears on a separate line. Right? So elems is just this big string. It's element 1, element 2, element 3, right? Separated by new lines. Right? Now I need to convert that big string back into an array. Right? So sorted. So to convert it into an array, I can just take that string and stick it inside of round brackets. Right? So when you do that, notice that elems here is not quoted. Right? If I double quote this doesn't work. So elems is not quoted, so that means any white space that's in the string, right, including the new lines, will cause those to become separate array elements. Right? So every time there's a new line, you'll get a new array element. Right? So that sorted now becomes your array of sorted elements. And so that's how you sort an array and put the contents into a new array. Is there a good way to do it? I haven't tried doing it. I don't know what happens if you write ARR equals here. I guess that works just fine. That will make a new array and assign ARR and assign that new array to ARR. So that would work fine. But you'll lose the original array, which probably doesn't matter in this particular case. Right? And so that's how you do it. So there's a lot of ideas flying around in this very small script. Right? There's a pipeline. There's a loop. Right? There's your looping over the elements of the array. There's a command substitution here to capture the output from sort. Right? And then there's the array construction on the next line. So that works unless your array has spaces or wildcards, right? The line that falls apart is this one right here, right? So that line there explicitly relies on the fact that elems is going to undergo word splitting, right? In order to get in order to get the elements into, in order to break each line into a separate array element, right? If your lines of text have spaces in them, then those lines of text will also undergo word splitting, right? So you'll end up with an array that has too many elements. If your lines of text happen to have wildcards like star, question mark, or square brackets, then file name expansion will happen here as well, right? So you have to watch out for that as well. All right, I guess the alternative is to write your own sorting algorithm, right? So implement like a selection sort or insertion sort in bash. Okay, unset. Okay, we don't really need to know about unset. Unset will delete an array or an array element. It'll delete a variable if you ask it to, right? And we've already seen examples of unset in some of the scripts that are in the notebooks. Okay, so these are all, oops, a reference to an array variable without, oh yeah, we know about this too. Okay, so if you refer to an array variable without its subscript, then that's a reference to the first element, to the element at index 0 of the array, right? So if months is the array January, February, March, and April, right? If you just use months on its own, you get the array element at index 0. Okay, functions. All right, so in bash, a bash function is like a function in any other programming language, sort of, right? So it represents basically a sequence of commands that you can call by name, right? So you can define a function two different ways in bash. You can use this syntax here, or you can use this syntax here, right? So the first syntax is the name, the keyword function, followed by the name of the function, followed by a space, sorry, the space is important, followed by a brace, and then the body of the function, right? Alternatively, you can use this syntax here. So the name of the function followed by a pair of round brackets, followed by a space, followed by the brace, and then the body of the function. The second version is preferred, that one. So this version only works in bash and a few other shells. This version works in most of the Unix shells. I think all, actually. All of the existing Unix shells understand this version of a function. Right, so that's the preferred version. That's the one I'm going to use. Right. Notice that the round brackets here, this looks like a parameter list, but as you'll see shortly, there is no parameter list in bash. Right? So that's always round bracket, closing round bracket. So here's a simple little function called greet. It does nothing but print hello, or at least that's what it looks like, right? So it looks like it does nothing but print hello, right? So there's my function, echo hello, right? The script, that's the first line of the script that actually gets run, right? So that's how you call the greet function, and that prints hello. Right? It actually does one other thing, but we'll get to that in a second. Okay, a function has access to other variables in the script. So this is the funny part about bash functions. They don't use scoping they don't use any scoping rules the way that you're used to, right? So you're used to creating local variables in a function, and then inside the function, and that function becomes only visible in that, the variable becomes visible only in that function, right? After you leave the function, it's no longer visible. It doesn't work that way in bash, right? So in bash, bash uses, where'd it go? Here? Oh, I don't need that. That was the example that we want to talk about right there, actually. Okay, so bash uses this technique called dynamic scoping to determine the visibility of variables. So basically, if you read this little quote here, that's the definition of dynamic scoping. Okay, so variables and their values become visible. Visible variables and their values are a result of the sequence of function calls that caused execution to reach the current function. Right? So, okay, what does that mean? Let's go back to PowerPoint. Okay, so in this script, you've got a function here, and then you've got a variable here. Right? So we've got a variable called var. Its value is global. Right? Then we call greet. Right? So greet comes up to here. Right? So in bash, that variable var is visible in this function here. Right? Because bash knows about this variable because it's interpreted this line of code already. Right? So it knows there's a variable called var. So that name var is usable up here, and the value of var is global in this case, is the string global. Right? So if you run this script, that will print out hello var is global. Right? There was no need to pass this variable to this function in order to use it here. Right? So bash functions, they have no explicit parameters. What's this one? Okay. So the same is true if the function calls another function. Right? So up here in greet, right? So we start down here, right? So var is global. Right? We call greet. So we jump up to here. Right? So this echo command prints hello var is global. Right? Now we declare another variable called var greet. Right? Or whatever else you want to call it. I don't know why I used var greet. Anyway, so we call var greet equals greet. Right? So this variable now appears in the bash, I guess. Bash is now aware of this variable called var greet. Right? And now there's this function call to leave. Right? So now we jump down to leave. Right? Inside leave uses var greet, and that's fine too. Right? So var greet becomes visible to leave because greet declared it up here. Right? And greet was called before leave was called in this script. Right? If you call leave in this script before calling greet, then that's just the empty string. Right? And then you get a variable called var greet that is the empty string. Right? This technique of dynamic scoping is what bash uses to determine the visibility of a variable. Now, if you want to, you can in fact declare a local variable. Right? So if you really want a local variable, that is a variable that's only visible inside the function that it's declared, then you use the keyword local. Right? So when you make a local variable, that hides any other variable that's in an enclosing scope. Right? So here we've got var. Right? There's our variable var. Its value is global. We call greet. So greet jumps up to here. Right? Greet declares a local variable called var. Right? So this variable var stays the same. It's still global. Right? But now the local variable greet appears here. Right? And so when this prints hello var is var, that prints greet. We call leave. Right? Jump down to here. Right? Now there's another local version of the variable var. Right? And it's equal to the string leave. So when this prints goodbye, var is blah, it prints leave. Right? Then we jump back up to here, and then we jump back down to here. Right? And now down here, var is unchanged. It's still global. Right? Because this variable var is actually different than that variable var because it's declared local. Right? Similarly, this variable var is different than that one and that one, again, because it's declared as being local. All right, now what about parameters and return values? Because, I mean, functions are most useful when they actually can take in parameters, right? So the functions do have parameters, but they're not explicitly named, right? Yeah, they're not explicitly named, right? And so instead, what you do is you use the positional parameters, just like you would use for command line arguments, right? So $1, that's the first argument that was passed to the function. Right? $2 was the second argument passed to the function. $3 is the third argument passed to the function, and so on, and so on, and so on. Right? When you call a function, it looks like you're just executing a command. Right? So there's no round brackets after the function name or anything like that. Right? You just type in the name of the function. If you want to pass in the parameters, you pass in, if you want to pass in arguments, you pass in the arguments as though they were command line arguments. Right? So argument space, argument space, argument space. Right. So here's a little function called test. Right? Test will accept up to 3 command line arguments. right? So $1, $2, $3, right? Dollar number, right? That's the number of arguments that are passed to the function, right? So the special parameter hashtag, I guess, right? It gets recycled when you call a function, right? So that's the number of arguments passed to the function. It's not the number of command line arguments at this point, right? Here, on that line, so a hashtag is the number of command line arguments, right? But inside the function, it's the number of arguments passed to the function, right? So if you call test with no arguments, right, it's not an error, right? $1 is not set, so param1 gets the empty string. $2 is not set, so param2 gets the empty string. $3 is not set, so param3 gets the empty string, right? Dollar number is 0. No command line arguments were passed to the function, right? So when you print out param1, param2, and param3, you'll get empty, empty, empty in this case, right? If you call it with one argument, right, then param1 gets set to A in this case, right? Param2 and param3 are both empty strings. The hashtag is equal to 1, right? Because there's one command line argument, right? In the fourth case, or I guess the fifth case, when you pass in 4 arguments, right, this function doesn't use $4, so it doesn't know anything about the D in this case, right? It gets the A, the B, the C. It also gets the D, but it never uses it, right? Again, not an error in bash. So you just recycle the positional parameters as your function parameters. Okay, what about return values? So the return values are stranger yet. Right? So the return value of a function is the exit status of the last command executed by the function. Right? So it's the exit status of the last command executed by the function. So in other words, the return value of test is the exit status of that echo command, right? So that echo command prints a valid string, so that's going to have an exit status of 0, right? There's no error printing that string. So test is going to return the value 0, right? Right? So it's the exit status of the last command executed in the function, right? So if you want to simulate returning a value, right? So if you want to return something else, right? So if you don't want a number that's between 0 and 255, because that's the range of valid return exit statuses, right? Then you have to do something else, right? And so the something else that you do, so one of the other things that you can do is you can send the value that you want to, or print the value that you want to return to standard output, right? So print the value that you want to return to standard output. In the rest of your script, you use command substitution to capture that output, right? And so what you can see here is that a function is, as far as bash is concerned, a function is just another command, right? It has an exit status, and like most other bash commands, it sends something to standard output, right? Or can send something to standard output, right? And in fact, you can actually use a bash function as a command. Right? So it's possible, if you tell bash where your functions are, you can use a function defined in some script file as a command. Right? So here's an example of quote unquote returning a value from a function. Right? This is a silly example because you would never write this function. Right? This is just going to compute x raised to the power y. Right? But if you wanted to compute that, you would just write that line. Okay, so here's an example if you wanted a function called pow. Right? That computes x raised to the power y. Right? You need 2 command line arguments, 2 parameters, right? So 2 arguments to the function, right? X and y. Here I'm using an arithmetic substitution to capture the value of x raised to the power y, and then I print that value, right? To capture that returned value, you use a command substitution here, right? So $ round bracket, call the function, right? Whatever that function prints, right, that gets captured using this command substitution here. Right? And then that gets stored in the variable z. Right? So that's one way of simulating returning a value from a function. Right? It's weird, but this is the way it works. Right? Oh, okay, so let's go to that notebook that actually contains all of this stuff. All right, so this is the function notebook. So let's look at some examples here. There's the Okay, so here's the calling a function script. Right, so here's our test function. It takes in 1, 2, and it takes in up to 3 parameters. Right, and here we're going to call the function with a bunch of different inputs. Right, so I'm going to call it with no arguments, 1 argument, 2 arguments, 3, and 4 arguments. Right. Oh, and I do something else too. Check if the arguments passed to the script are still intact. Oh yeah, right. So let's do that. So let's run the script. Okay, so here I'm going to run the script. Right, so I've got the script. I'm going to pass in 5 command line arguments to the script. Right. Now remember, in our function up here, we're using $1, $2, and $hashtag, right, as the first, second, and third arguments passed to the script, and the number of arguments. Right. So the question here is, if you're using $1, $2, $3, and hashtag up here, does that actually change or overwrite the values of $1, $2, of the positional parameters and of $number inside the script itself? Right. So remember, inside the script itself, right, $number is supposed to be the number of command line arguments. In this case, it should be 5. Right? And it's not clear, from what I've told you so far, whether or not this stays 5 or not. Similarly, it's not clear if the positional parameters, $1, $2, and $3, stay the same. I'll explain what shift does in a second. Okay, so let's run that and see what happens. Okay, so we call it 5 times, right? First time, no arguments, right? So 0 arguments pass to the function. The parameters are all empty, right? 1 argument passed to the function, right? Only the first one has a value, right? 2 arguments passed, so the first 2 have a value. 3 arguments passed, the first 3 have a value. 4 arguments passed, right? So the first 3 have a value, the 4th one's not used. Now, what about the 5 arguments that were originally passed to the script? Well, there are still 5, right? So even after using $number and $1, $2, $3 inside the function, right, the values of the hashtag and of the positional parameters, they're all intact, right? So they all stay the same, which is good, because that's what you would expect it. That's the way you'd expect things to work. All right. Okay. So there is another way to return a value from a function, right? So you can use the return statement, right? So a return statement will stop a function at the point of the return statement, and it will set the exit status of the function to whatever value you give to return, right? Note the blue. Oh wait, there's something back here. Sorry, I forgot to tell you what shift does up here. Okay, this little loop here is a bit funny. So I've got a loop up here. So this prints out the number of arguments passed to the script, so that it should be 5 here, right? Then I'm going to loop over the elements. I'm going to loop over the positional parameters, right? Now there's a problem when you loop over the positional parameters, right? So in your loop, I want to access $I, right? But I can't. That doesn't work, right? If you try to do $I, then what you get is, if you try to access $I, then all you get are the numbers 1, 2, 3, 4, and 5 in this case, right? Because you take the value of I and you substitute that for the $I, right? If I want to access $1, $2, $3, I have to use $1, $2, $3, et cetera, et cetera, et cetera, right? So in this case, that becomes inconvenient, right? So I can't do it using the counting style loop, right? But what you can do is you can print out the value of $1 each time, right? And then use this command called shift, right? So shift shifts the command line arguments 1 position to the left, right? So if you have argument 1, then argument 2, then argument 3, right? The first time through the loop, $1 is argument 1, right? And then you shift. So that shifts argument 2 to argument 1. It shifts argument 3 to argument 2, right? And now you have 2 command line arguments, right? So the next time through the loop, $1 is now the original second command line argument, right? And then the third time through the loop, $1 is now the original third command line argument, right? So shifts command line arguments to the left by 1 position, right? If you want to shift by more than one position, you can put in an integer value after shift, right? So shift space 3 will shift them by 3 positions to the left, right? Anything on the left that falls off the front just disappears, right? It doesn't wrap around. So when you're reading bash scripts that process a bunch of command line arguments, you'll often see them use, shift as the way, shift inside a loop to process the command line arguments one at a time. Right? You don't have to do it this way, it's just the way a lot of scripts do it. Okay, so return sets the exit status of the function, right? Stops the script from running, sets the exit status of the function. So this function here sets the exit status to 0, randomly sets its exit status to 0 or 1, depending on whether or not random is even or odd, right? So if random is even, then it sets the exit status of the function to 0, right? If the value in random is odd, it sets the exit status of the function to 1, right? So if you run that, I think it runs, yes, right? So that one, apparently that number was odd, that number is odd, that number is even, right? So return is one way to set an integer exit. So return is one way to set the exit status of a function. Right? All right, this is a slightly better example of returning a value by printing it. Right? So here's the function max2, right? Takes in 2 command line arguments and assumes that they're integer values, returns the larger of the 2 values. Right? So if the first argument is bigger than or equal to the second argument, it prints the first argument. Otherwise, it prints the second argument. Right? The if statement ends. The exit status of the function is the exit status of the if statement, which in this case runs without error. So the exit status of this function is always 0. Right? Is int. Here's a function that sets its exit status to 0. If the argument is an integer, it sets the exit status to 1 otherwise. Right? So isInt takes in 1 command line argument. Right? If it's an integer, right? So remember, there's our regular expression for is it an integer. Right? So in other words, starts with a 1 or 0, plus or minus signs, right? Followed by 1 or more digits. So if it's an integer, it sets the exit status to 0. If it's not an integer, it sets the exit status to 1. Right? And now in our script, right, if we have no command line arguments, then we exit with an error. Right? If the first command line argument is an int, right, then I've got this variable called high, which is going to store the maximum value. Right? So that's going to be equal to the first argument. Right? If the first argument is not an int, then that's an error, so we're going to exit. Right? What is this doing? Max. This one is computing the max of a bunch of arguments on the command line. Right? So while the number of arguments on the command line are greater than 0, right, if that is greater, sorry, do I have a shift in here? There should be a shift. No, I don't. Okay, never mind. So if is int high. Okay, that's fine. So if the first argument is an integer value, I'm going to call max. Right? So I'm going to call max2, passing in the current highest value and the command line argument and the current command line argument. Right? So max2 is going to print which one's the higher value. I'm going to capture that using a command substitution, and I'm going to store that back in high. Right? If that argument on the command line argument is not an integer value, we exit with an error. Right? And now I process the next command line argument by shifting them all over. Right? So when you run that script with 1574, it's going to set high to 1. It's then going to compare 1 to high, and it's going to get back 1. Then it's going to shift the arguments. Right? So 1 disappears, and you have 574. Right? So now it's going to compare the 5 to high. High will get set to 5. Then it's going to shift the arguments, so it'll process 74. right? 7 gets compared to high, which is 5, so 7 becomes the new high, right? Shifts the arguments, and now it processes the 4, right? 4 gets compared to 7, 7's bigger than 4, so the final output will be 7, right? If I've done everything right. Right? This isn't the only way to write this, right? You can write a loop, process each element of the loop, and repeatedly call max2 inside the loop, right? This is just one example. This is just one way to do it. There's a little blue box here that tells you something. So whenever you use a command substitution like this, or anything else, right? What happens is that command runs inside of a subshell. So in other words, bash creates a new bash shell to execute this function, to execute that command, right? So that command ends up running in a new shell. It prints whatever it prints to standard output. That gets captured with the command substitution, and then that other shell disappears, right? So the command runs in a separate subshell. Now the problem is, for a small function like this, it doesn't matter, right? But it's inefficient creating a new shell every time to run a simple command, right? And so that's the disadvantage of using this by using a command substitution to capture printed output from a function, right? It becomes inefficient. Okay, so here's dynamic scoping again. You can read this. The example here is a little bit more sophisticated than what's in the notes, than what is in the slides, but you can read this in your own time. We write Remax. Okay, so the other way to quote unquote return a value from a function is to not really return the value from a function. Instead, the idea is store the result in a variable that's created before you call the function, right? So here's max2 again. It's going to compute the maximum of 2 values. This time it's going to store the larger value in this variable called high, right? Which is fine, right? So down here in our main script, right, when I call max, right, I'm going to compare the current high to the first command line argument, right? That just stores the value in high each time, right? So when you go up and look here, right, that just gets stored in that variable high, right? And so high becomes, I guess you guys know it as a global variable from Python, right? So high basically becomes a global variable in this case, right? And so here you're using a global variable to avoid creating a subshell when you use command substitution, right? Either technique is fine. For a simple little function like this one, right, it's almost certainly better to store it inside of a variable than to print it and then capture the printed output with command substitution. Right? You just have to remember that whatever you do, you have to make sure that this variable exists before you call max2. Right? If that variable doesn't exist before you call max2, then it gets created on the fly. And if you're storing it in a different variable, right? Suppose you're storing it in the variable big H, big I. This doesn't do the right thing anymore, right? So you have to be a little bit careful about that. Okay, but this one works the exact same way as the other one, right? So that one actually works. All right, so that's functions in Bash. Any questions about functions or using them? Right, okay, quickly to summarize then, they do have parameters. Functions have parameters. If you want the arguments, or if you want the parameters, they're just the positional parameters, right? So $1, $2, $3, dollar number sign is the number of command line, number of arguments passed to the function. If you want to return something from a function, either use a global variable, store the result in a global variable, or print the output and then capture the output using command substitution. Or if your function happens to return an int, you can use an int between 0 and 255. You can set the exit status of the function and use the exit status as the return value. Right? So those are your 3 choices. Why it's done that way is just because. Right? That's the way it works in Bash. Right? All right. Yes?
Can you go shift again?
Can I go what, sir?
Go over shift again?
Yeah, sure. So it's easier to show you with an example. Okay, So here, when I call that script, right, $1 is 5, $2 is 10, and $3 is 1, right?
Yeah.
Okay. Inside the script, if I write shift once, right, $1 becomes, so the arguments get shifted to the left.
But you write shift like when it's running.
Sorry? When the script runs.
Yeah.
Yeah.
It's not at the beginning, it's in the middle of the script.
Yeah, yeah. Right? So there are my 3 command line arguments, right? So if I use $1 in my script, that's going to be 5, right? After using $1, if I write shift, right, then all the arguments shift one place to the left, right? So 10 becomes $1, 1 becomes $2, right? So now if I use $1 again, right, it's now 10, right? And then if I shift again, $1 becomes 1. Yeah, that's all it does. It just shifts the arguments to the left. Yeah. It's very common to see in scripts that process command line arguments one at a time. But it's not the only way to do it, right? You can write a loop and loop over them instead. Okay, any other questions? All right, that's all I wanted to cover today. Have a good reading week if I don't see you in 124.